Ever wonder why some math problems take seconds, while others would take a billion years to solve? It all comes down to complexity classes. Today, we're breaking down the two heavyweights, BPP and BQP. First up, BPP. It stands for Bounded Error Probabilistic Polynomial Time. Sounds fancy, right? But think of it as a classical computer that is allowed to flip coins. In BPP, the computer doesn't just follow a straight line, it uses randomness to find shortcuts. The bounded error part means it has to be right at least 2/3 of the time. A perfect example, primality testing. Before 2002, the fastest way to check if a massive number was prime was a BPP algorithm called Miller-Rabin. It's fast, it's efficient, and even though there's a tiny chance of error, we can make that chance smaller than a lightning strike hitting your house. Now, let's go deeper. What happens when you swap coin flips for qubits? You get BQP, bounded error quantum polynomial time. This is the playground of quantum computers. While a BPP computer uses probability, a BQP computer uses interference. Imagine you're in a maze. A classical computer tries one path at a time. A BPP computer might pick paths randomly. But a BQP computer? It acts like a wave, exploring all paths at once and using destructive interference to cancel out the wrong turns and constructive interference to amplify the right answer. In BQP, we still have that 2/3 success rule. But because of quantum logic, we can solve things that BPP simply cannot handle in a human lifetime. It's like upgrading from a bicycle to a warp drive engine. The ultimate example of BQP's power is Shor's algorithm. If you want to factor a 2048-bit number, the kind that protects your bank account, a BPP computer would be crunching numbers until the sun dies. But for a BQP computer, it's just a Tuesday afternoon. So, here is the bottom line. BPP is what our best classical computers can do using randomness. BQP is what quantum computers can do using superposition and interference. Every problem in BPP is also in BQP, but BQP is way more powerful. We don't think BQP can solve everything, like the hardest puzzles in the world, but it's enough to redefine medicine, cryptography, and physics as we know it. Which one do you think will change the world first? Drop a comment below, and don't forget to hit subscribe for more quantum breakdowns.